All right, so welcome to 11.8. We're now going to use the tools we've been learning to simplify fractions or do division of polynomials. Let's see that. All right, so let's remind ourselves the things we've learned. All right, so to factor this, it would be x, and we have a 5, and I think it's x minus 5, x plus 1, yes. And here we have an x, and we have, they're both going to be the same because this is a plus and that's a minus, and minus 2, minus 5. Okay, and simplifying fractions. Can we just cross out these x's? Yes, we can. This is y over z. Now, can we cross out this x minus? Now, we can't cross out x's here because this is a group. So when you're doing this canceling, it's got to do the whole group together. So this whole x minus 5 and that whole x minus 5. And then you don't need the parentheses anymore because nothing's next to it. But that is what that simplifies to. And that's what we're doing today. Now you can't cancel those x's because they're part of a group. X plus 1 is one group. X minus 2 is another group. So you can't do that, is what I'm saying. All right, you just can do this. You can cancel entire groups. Okay, so let's see this. So what we're going to do today, I'll give you this, and what that is x squared plus 2x minus 35 divided by x minus 5. Yeah, and in high school, you will do things like this. You'll actually do this division. There's a procedure, very much like long division. We are not going to do that. We're going to do a different way, a simpler way. We're going to factor it and look for things to cancel. So we have an x minus 5 here. So we're looking for an x minus 5, and I found one. And if there's an x minus 5 factor there, then you need the other factor, which was x plus 7. So if you have two factors that are the same, top and bottom, you can cancel them, just like that, just like if it was x by itself, or y by itself, or 3 over 3, anything. And this is x plus 7 over 1, which is x plus 7. So think about this. So if I tell you now x is 3, that equals 10, right? Guess what? If x is 3, that equals 10 also. They are equal. Would you say that's way simpler? That's why it's called simplifying. All right, so now, remember that you can never have 0 in a denominator. Never. All right? So these things we've been learning, we want them to be true for all values of x. But when we're doing division, when you're doing fractions, you can't have a 0 in the denominator. So what number can't x be? Well, x can't be 5, right? This can't be 0. So what would make that equal to 0? Well, I mean, hopefully you can do it in your head, but you'd add 5 to both sides, right? X can't be 5. X can be any other number. If we put any other number there, you'll get a value for x. We put 5 in there, you get 4 times 5 plus 1 on the top, which is 21. You get 5 minus 5, which is 0, and 21 over 0 is not 0. It is what? It is undefined. So when we do our work today, there are going to be values of x that are not included. They're excluded. All right, so what would make this equal to 0? Well, in this case, it is 0. 0. Now, remember, it's not x that it's in the case is what's going to make the denominator equal to 0. 6 times 0 is 0. Any other number for x that is defined. Now, this one has two numbers that will make it equal to 0. Well, let's see. One of them is 3. So let's see that. All right, if I put 3 on the top, you get 5 times 3 is 15 plus 7 is 22. On the bottom, you get 3 minus 3 times 3 plus 2. Well, you get 0 times 5. What's 0 times 5? 0. This is undefined. So x cannot equal 3. 3 is excluded. What else will make the bottom here equal to 0? Well, negative 2 will also make x can't be negative 2. What if it's negative 2? Well, on the top, you get 5 times negative 2 plus 7. Negative 5 times negative 2, negative 10 plus 7, negative 3. That really doesn't matter. But on the bottom, if both x's are negative 2, negative 2 minus 3, negative 5, negative 2 plus 2, 0. Negative 5 times 0, 0. Not defined. All right, so x cannot equal 3, x cannot equal negative 2. Those numbers are excluded. All right, so here we go. So how do we do our homework? How do we simplify this? All right, so we have an x minus 3 on the bottom. So unless we can find an x minus 3 factor up here, we're not going to be able to cross anything out. So let's see if we can. So we have an x minus 3. Can I find a factor that goes with that here? Does x plus 2 work? Let's see. No. No. I'm very confused here. No, x minus 2. I lost my mind for a second. X, right? X minus 3 times x minus 2. X squared minus 3. Yeah, so there they are. And so this simplifies to x minus 2 over 1, which is x minus 2, right? If x is 10, that equals 8. Guess what? If x is 10, that also equals 8. But this is way simpler, right? So you're looking for common factors. Okay, let's see that again. All right, so we have an x plus 6 up here. Now we're looking for an x plus 6 down here so we can cancel it. Let's see. So then this one would have to be 2x plus 1. Does that work? X squared, outer plus 1x plus 12x. Yes. And so this is 1 over 2x plus 1. Okay. Now, what number can't x be? Well, x here can't be 3. And the reason is this. Look, if you put 3 minus 3 in there, you get 3 minus 2 equals 1, right? But if you put 3 here, you're going to get 0 on the bottom, and it's going to be undefined. So this is true. These two are equal for any other value. Any other number, these two are equal, but not for 3. So 3 is excluded. And let's look at the other one, what was excluded. So over here, all right, what would make that? Well, what would make that equal to 0? Subtract 1 from both sides. 2x equals negative 1. Divide by 2. X can't equal negative 1/2. Yeah. Any other number, x equals negative 5.1, 0.51, something very close to negative 1/2, or negative 1/3 will work. It's just that one little number, you get an expression that is undefined. All right, so we're going to factor these. Now, there's not just a binomial term to look for here. So what you do in this case, you look for the one that's easier for you to factor. I'm going to factor the top because it's plus and plus. So, right, when they're both plus, it is easier. And I think it's 4 and 1, right? So for the bottom one, we're looking for an x plus 1 or an x plus 4. I think we're going to find an x plus 1 and then maybe an x minus 4. Let's see. Are those the fact x squared plus minus 4x plus 1? Yes. So that's it. So it's the x plus 1s that cancel. And you get x plus 4 over x minus 4. Okay. And notice, x can't be positive 4 there, or that denominator will be 0. And you can't cancel the 4s, you can't cancel the x's. They're part of a group. You have to cancel entire groups, not parts of groups. All right, so this and this are the same thing, right? This is x squared plus 7x plus 6 divided by x plus 1. So we're going to look for an x plus 1 factor. And I think the other one is x plus 6. This is a pretty easy one. You cross those out, and this equals x plus 6. All right, this is x minus 3 over, right? The second number is the thing that goes on the bottom. So we're looking for an x minus 3 factor, so we can do some canceling. And I think it's x minus 3 times x minus 3. Yeah, this was a perfect square down there. So they can cancel one of those x minus 3s, and you get 1 over x minus 3. When everything's gone, up top you get a 1. Okay, so again, we're going to use everything we've been learning. So we need to get an x plus 5 here. And notice, all right, that there is a common factor of 2 here. So let's take that out first. 2 times x squared plus 6x plus 5, yes? So then we have a 2 times, and we're trying to get an x plus 5. What else? Do we have an x plus 1? Yes, that's what it is. So the x plus 5's cancel, and you end up with 2 times x plus 1. I'll write this out, over 1, which is 2 times x plus 1. It's true. Try another one here. So again, here, let's get this out of the way. All right, so we're looking for x minus 1, and we're going to take a 5 out, right? Because those all have a common factor of 5. 5x squared minus 4x plus 3, right? And we're looking for this to be, and you can do it this way. You can cross out this way and go 5 times x minus 1 times x minus 3. Okay, those cancel out, and you get 1 over 3 times x minus 3. Okay. Right, so it's very tempting here to look at this and cancel the 7x. You can't. You can't, because we have a group here. That is stuck together. Even those parentheses there are implied. Okay, they are there. But what you can do is remove a 7 and get x minus 1. And so then this 7 is outside the group. So once it's outside the group, then you can cancel the 7's. And the answer to this is x minus 1 over x. You can't cancel those x's though, because the x minus 1 is still linked in his group with minus 1. All right. Right. Distributive property says, right, well, let's just talk about distributive property, is that, right, says that you have to divide, right, you could write this as this, right, you have to divide every part of a group, right, yeah, and believe it or not, yeah, that does equal 1, and that does, I can manipulate that to look like that. I don't think that's makes it easier or helpful, but that is the truth. Okay, so once again, I want to cancel this 5, I want to cancel this x, but I can't because there's a group up there. But I think I can take out a 5x there and get x minus 5. Can I do that? 5x squared minus, yes. So then I can cancel this 5, I can cancel this x because they're outside that group, and you get x minus 5 over 1, which is x minus 5. One more time, again, we got groups. But on top, I can take out an x and get x squared minus 9. On the bottom, I can take out a 3x, and I get x minus 3. Interesting. Well, I can, but look at x squared minus 9. That's a difference of perfect squares. I can make x minus 3 times x plus 3 out of that. And so now let's look what I have. Okay, so the x's cancel, the x minus 3's cancel, and I have x plus 3 over 3. We cannot cancel those 3's because the x plus 3 is a group. Okay, so what numbers will make that denominator equal to 0? If x is 2, we'll get 0 on the denominator, right? Because 0 times anything, it'll be 2 minus 5, right, over 0 times 6. Which is negative 3 over 0, which is undefined. You don't have to write all that out. Anything that will make the denominator equal to 0 is excluded. What else is excluded? X equals negative 4 is excluded because negative 4 plus 4 is 0. And for 0 times anything is 0. All right, so we're looking for an x plus 4 here. And so we can do some canceling, hopefully. And so then this must be 2x plus 1. Does that work? Yes, it does. So the answer to this is 2x plus 1. And if you're asked, x can't equal negative 4, because that will make that equal to 0. Well, equal to the denominator equal to 0, the whole thing undefined. Okay, so I'm going to factor the top and get x minus 5x plus 2, I think so. Yeah, let me just, yes, that's good. So now I'm looking for x minus 5 or x plus 2. I don't think there's any way I'm going to get an x plus 2 out of a 35. So there must be x minus 5 here. All right, x minus 5, and that would be x plus 7. Yes, so the x minus 5's cancel, and you get x plus 2 over x plus 7. Okay, so here I see a common factor of -3. So we get x squared plus, no, not plus 4, minus 4. Now we're looking for x squared minus 4. No, that's not going to work. But x squared minus 4 could be x minus 2 times x plus 2. Yes, difference of perfect squares. So now we're looking for one of those out of this. And this has to be all plus, right? These are both plus. So it's x plus 2 times x plus 5. Those cancel. The -3 is still there up top. So it's -3 times x plus 2 over x plus 5. Oh, yeah, and some teachers might have you redistribute that. That's ridiculous. Don't do that. Well, this one on the bottom is x minus 7, x plus 7, right? So we're looking for that on the top. Oh, this is x minus 7 times x minus 7, right? The top is a perfect square trinomial. The bottom, let's make sure we see the difference here. That's a perfect square trinomial. This is the difference of two perfect squares. The parts are perfect squares, but the whole thing is not, the difference of perfect squares. And that all leads us to that you can cancel those x minus 7s there, and the answer to this is x minus 7 over x plus 7. So if you see that, that's the same thing, oops, 25, I'm very sloppy, as this. And so we're looking for a 3x minus 5 out of that top. So 3x minus 5. If you can't get 3x minus 5, then you would be done. It'd be simplified. And 3x plus 5, is that the difference of perfect squares? I think it is. And so these cancel, and the answer is 3x plus 5. Good luck with the homework.